To determine the correct fuse protection for a 45 kilowatts, 480 volts, three-phase heater, you'll need to perform a series of calculations and consider various factors. The initial calculation involves finding the current drawn by the heater. You correctly identified that the formula for this is the heater power divided by the line voltage. So 45,000 watts divided by 480 volts equals 93.75 amps. Because it is a three-phase system, you must also consider the square root of 3, which is approximately 1.73. Therefore, divide the 93.75 amps by 1.73, and you get 54.19 amps. Now let's discuss nominal fuse size. While 54.19 amps is the calculated current, it is crucial to select a fuse with a slightly higher rating. Your suggestion of using a 60 amps fuse as the next greatest nominal size is a good starting point. However, you need to consider the continuous load and potential derating factors. Electrical codes often require that fuses be rated at least 125% of the continuous load to prevent nuisance tripping. A continuous load is a load that operates for 3 IOs or more. If the heater operates continuously, you may need a fuse larger than 60 amps. Now let's get into derating and pro-ratings. Fuses are susceptible to temperature derating, especially in high-temperature environments. The fuse manufacturer provides derating curves that show how the fuse's current carrying capacity decreases with increasing ambient temperature. Consult the fuse datasheet to determine the appropriate derating factor for the specific fuse and application. Pro ratings, on the other hand, indicate the fuse's ability to handle inrush currents. Some heaters, especially those with resistive elements, may draw a significant inrush current when initially energized. A pro-rated fuse can withstand this inrush current without blowing unnecessarily. Now let's discuss some recommended fuses. For standard fuse, one option is the little fuse KTKR 70 amps. This fuse is a time delay fuse suitable for general purpose applications and can handle some inrush current. For pro fuse designed to handle higher inrush currents, consider the Bussmann FWH-200 100 amps fuse. This fuse is a fast-acting fuse with a high interrupting rating, making it suitable for protecting against short circuits and overloads. Now let's explore some additional considerations. The fuse size should also consider the maximum short circuit current available at the installation point. This is known as the available fault current. The fuse must have an interrupting rating equal to or greater than the available fault current to safely interrupt a short circuit. You can obtain the available fault current from the utility company or by performing a short circuit study. Make sure that the fuse holders are rated for the appropriate voltage and current. Use fuse holders that are specifically designed for the type and size of fuses being used. Check that all fuse holders are in good condition and free from corrosion or damage. Proper installation and maintenance are crucial for safe operation. Install the fuses in accordance with the manufacturer's instructions and all applicable electrical codes. Regularly inspect the fuses and fuse holders for signs of overheating, damage, or corrosion. Replace any damaged or defective components immediately. It is also important to remember that the National Electrical Code, or NEC, provides guidelines for fuse sizing and protection of electrical equipment. Consult the NEC for specific requirements related to your application. For example, NEC Section 430.52 provides guidelines for motor circuit protection, which may be relevant if the heater is part of a larger system with motors. NEC Table 310.16 provides ampacity ratings for conductors, which is important for ensuring that the conductors are properly sized for the load and the fuse protection. The formula 45,000 watts/480 volts gives you 93.75 amps, which is the total current for all three phases. Dividing this value by the square root of 3 gives you the current per phase, which is approximately 54.19 amps. This value is important for selecting the appropriate fuse size for each phase. Now let's discuss a few more details of fuse types. There are two primary types of fuses: time delay fuses and fast acting fuses. Time delay fuses, also known as dual-element fuses, are designed to withstand temporary overloads, such as motor starting currents, without blowing. Fast-acting fuses, on the other hand, are designed to quickly interrupt short circuits and are typically used for protecting sensitive electronic components. For heater applications, time delay fuses are generally preferred because they can handle the inrush current that may occur when the heater is initially energized. However, fast-acting fuses may be appropriate in certain situations where rapid protection is required. Here is more information on fuse selection. When selecting a fuse, it is important to consider not only the current rating but also the voltage rating, interrupting rating, and time current characteristics. The voltage rating of the fuse must be equal to or greater than the system voltage. The interrupting rating of the fuse must be equal to or greater than the available fault current. The time current characteristics of the fuse describe how long it takes for the fuse to blow at different current levels. These characteristics are important for ensuring that the fuse provides adequate protection without nuisance tripping. Here are some additional safety precautions you should take. Always to energize the circuit before working on fuses or fuse holders. Use insulated tools to prevent electrical shock. Wear appropriate personal protective equipment, such as safety glasses and gloves. Never replace a fuse with a fuse of a higher rating. This can overload the circuit and create a fire hazard. If a fuse repeatedly blows, investigate the cause of the overload before replacing the fuse. Now let's explore the concept of selective coordination. Selective coordination is a protection scheme where the overcurrent protective devices, such as fuses and circuit breakers, are coordinated to isolate a fault to the smallest possible area. This means that the fuse or circuit breaker closest to the fault should trip first, while upstream devices remain closed. Selective coordination is important for minimizing downtime and preventing unnecessary outages. To achieve selective coordination, it is necessary to carefully select and coordinate the time current characteristics of the overcurrent protective devices. This typically involves using fuses or circuit breakers with different time delay characteristics. Now let's talk about fuse testing and maintenance. Regular testing and maintenance of fuses and fuse holders are essential for ensuring their proper operation. Fuses can be tested using a multimeter to verify continuity. Fuse holders should be inspected for signs of corrosion, damage, or overheating. If any problems are found, the fuses or fuse holders should be replaced immediately. Here is some information on troubleshooting fuse failures. If a fuse blows, it is important to determine the cause of the failure before replacing the fuse. Common causes of fuse failures include overloads, short circuits, and ground faults. An overload occurs when the current in a circuit exceeds the rated capacity of the fuse. A short circuit occurs when there is an unintended connection between two conductors. A ground fault occurs when there is an unintended connection between a conductor and ground. To troubleshoot a fuse failure, first to energize the circuit and inspect the wiring for any signs of damage or loose connections. Then use a multimeter to check for continuity between conductors and ground. If you find an overload, short circuit, or ground fault, repair the problem before replacing the fuse. In some cases, it may be necessary to use a clamp meter to measure the current in the circuit to determine the cause of the overload. Now let's talk about energy efficiency and fuse selection. While fuses are primarily used for protection, they can also have an impact on energy efficiency. Fuses with lower resistance will dissipate less power and generate less heat. This can improve the overall energy efficiency of the system. When selecting fuses, consider using fuses with low resistance and high energy efficiency ratings. Now let's explore the topic of arc flash protection. Arc flash is a dangerous electrical hazard that can occur when there is a short circuit or ground fault in electrical equipment. Arc flash events can generate intense heat, pressure, and light, which can cause severe burns, injuries, and even death. To protect against arc flash hazards, it is important to implement appropriate arc flash protection measures. These measures may include using arc-resistant equipment, installing arc flash relays, and wearing appropriate personal protective equipment. Fuses can also play a role in arc flash protection by quickly interrupting short circuits and reducing the duration of arc flash events. Fuses with high interrupting ratings and fast-acting characteristics can help to minimize the severity of arc flash hazards. In summary, selecting the correct fuse for a 45 kilowatts, 480 volts, three-phase heater involves several steps. Firstly, calculate the full load current. Secondly, determine the appropriate fuse size based on the continuous load and derating factors. Thirdly, select a fuse with an appropriate voltage rating, interrupting rating, and time current characteristics. Fourthly, consider the potential for inrush currents and select a fuse with a pro rating if necessary. Fifthly, ensure that the fuse holders are properly rated and installed. Sixthly, implement appropriate arc flash protection measures. Lastly, regularly inspect and maintain the fuses and fuse holders to ensure their proper operation. By following these steps, you can ensure that the heater is properly protected and that the electrical system operates safely and reliably. Here is some additional information about fuse standards and certifications. Fuses are subject to various standards and certifications such as Underwriters Laboratories, or UL, and International Electrotechnical Commission, or IC, standards. These standards specify the performance and safety requirements for fuses. When selecting fuses, it is important to choose fuses that are certified to the appropriate standards for your application. UL-listed fuses, for example, have been tested and certified by UL to meet specific safety requirements. IEC-certified fuses have been tested and certified by IEC to meet international safety standards. Using certified fuses can help to ensure that the fuses will perform reliably and safely in the intended application. Furthermore, it is important to understand the different classes of fuses. Fuses are classified based on their performance characteristics and intended applications. Some common fuse classes include general-purpose time delay, fast-acting, and current limiting. General-purpose fuses are designed for general-purpose protection of electrical circuits and equipment. Time delay fuses are designed to withstand temporary overloads, such as motor starting currents, without blowing. Fast-acting fuses are designed to quickly interrupt short circuits and are typically used for protecting sensitive electronic components. Current-limiting fuses are designed to limit the magnitude of fault currents, which can help to reduce the severity of arc flash events. The appropriate fuse class for a particular application will depend on the specific requirements of the application. Here are some final tips for selecting and using fuses safely. Always refer to the manufacturer's specifications and recommendations when selecting and using fuses. Use the correct fuse size and type for the application. Install fuses in accordance with all applicable electrical codes and regulations. Always energize the circuit before working on fuses or fuse holders. Use insulated tools to prevent electrical shock. Wear appropriate personal protective equipment such as safety glasses and gloves. Never bypass or tamper with fuses. Replace damaged or defective fuses immediately. Train personnel on proper fuse selection, installation, and maintenance procedures. By following these tips, you can help to ensure that fuses are used safely and effectively to protect electrical circuits and equipment. Remember that proper fuse selection and application are essential for electrical safety. Always consult with a qualified electrician or electrical engineer if you have any questions or concerns about fuse sizing or protection. Additionally, consider the environment in which the heater and fuse will operate. High ambient temperatures can affect the performance of fuses and other electrical components. If the heater is located in a high-temperature environment, it may be necessary to use a fuse with a high current rating or to provide additional cooling to the fuse. Humidity in corrosive environments can also affect the performance of fuses and fuse holders. If the heater is located in a humid or corrosive environment, it may be necessary to use fuses and fuse holders that are specifically designed for these conditions. Finally, remember that electrical codes and regulations are constantly evolving. It is important to stay up to date on the latest codes and regulations to ensure that your electrical system complies with all applicable requirements. In the United States, the National Electrical Code, or NEC, is the primary source of electrical codes and regulations. The NEC is updated every 3 years, so it is important to have access to the latest version of the code. Other countries have their own electrical codes and regulations, so be sure to comply with the codes and regulations that are applicable in your location. Electrical work can be dangerous, so it is important to take all necessary safety precautions. Always work with a qualified electrician or electrical engineer if you are not comfortable performing electrical work yourself. By following these guidelines, you can help to ensure that your electrical system is safe and reliable. The initial calculation is correct. You take the wattage of the heater, which is 45,000 watts, and divide it by the voltage, which is 480 volts. This gives you 93.75 amps. However, since this is a three-phase system, you need to divide by the square root of 3, which is approximately 1.73. So, 93.75 amps divided by 1.73 equals approximately 54.19 amps. Next, you need to consider the continuous load. If the heater operates for 3 hours or more continuously, the NEC requires that the fuse be rated at 125% of the continuous load. In this case, 125% of 54.19 amps is approximately 67.74 amps. So, the next standard fuse size above 67.74 amps would be 70 amps. However, there are also derating factors to consider. Fuses are typically derated for temperature. The higher the ambient temperature, the lower the fuse's current carrying capacity. You should consult the fuse manufacturer's specifications to determine the appropriate derating factor for the specific fuse and application. Additionally, some fuses have what is called a prorating, which indicates that the fuse is designed to handle inrush currents. Inrush currents are the high currents that occur when electrical equipment is first turned on. If the heater has a significant inrush current, you may need to use a fuse with a prorating. Based on these considerations, a 70 amps time delay fuse would likely be a good choice for this application. A time delay fuse is designed to withstand temporary overloads such as inrush currents without blowing. The little fuse KTKR 70 amps fuse is a suitable option. For a pro fuse, designed to handle higher inrush currents, the Busman FWH-200 100 amps is a good option. However, you should always consult with a qualified electrician or electrical engineer to determine the appropriate fuse size and type for your specific application. They will be able to take into account all of the relevant factors, such as the continuous load, derating factors, inrush currents, and applicable electrical codes.